Hey everyone, so we're going to be continuing solving equations today by substitution. We are not going to be dealing with equations that are set equal to the same variable. We're going to be taking a look at ones that are a little bit more complicated. So definitely take notes on this lesson. Okay, so when solving systems of equations, we use the substitution method when we are provided an x equals or a y equals equation. Previously, we saw when both equations had a y equals or an x equals. Today, only one of them is going to have an x equals or a y equals. Okay, so it is going to be a little different. So here we have y equals 6x minus 11 and negative 2x minus 3y equals negative 7. So the first thing that we want to do is identify that y equals or x equals equation. So obviously we have our first equation up here. That is our y equals, and we have y equals 6x minus 11. So what I'm going to do is circle this 6x minus 11. Okay, so what we're going to do is substitute that expression into that variable. So y is equal to 6x minus 11. We're going to take that expression, 6x minus 11, and we're going to substitute it in for y because that's what it's equal to. It's equal to y. So watch what happens here. I'm going to bring everything else down. That stays the same. Negative 2x minus 3. And instead of writing y, we're going to include that 6x minus 11. So we'll just put that minus 11. And we are still going to set that equal to our negative 7. Okay, so you can see everything in this second equation stayed the same. The only thing that changed was this y value, and instead of writing y, we substituted in that 6x minus 11. So now we want to solve for that first variable. In this case, it's x. So we're going to solve this equation. Now we have something right outside parentheses, so that means we're going to distribute. So we're going to distribute negative 3 to both of these terms. So we get negative 3 times 6x gives us negative 18x. And then we have negative 3 times negative 11. Negative times negative is a positive. So it's going to give us positive 33. And then I'm going to bring everything else that we didn't touch down. Okay, if you want, you can draw your train tracks. These are a little bit more complicated solving equations, so to stay organized, we can draw those train tracks. Okay, so from there, we're going to evaluate our equation here and say, okay, what can we do from here? Hopefully you notice we have some like terms, so we're going to combine those first. We have a negative 2x and a negative 18x. When we combine that, we get negative 20x. And let's bring everything else down. So we have that plus 33. And we have that minus 7. Now let's subtract our 33 on both sides. That cancels. We get negative 20x is equal to negative 40. Negative 7, so that's same signs add and keep. And then that last step, divide by negative 20 to get that x by itself. We get x is equal to positive 2. Negative divided by negative is a positive. So when we substituted in for this y value, we got x is equal to negative 2. After we looked at our equation, we had to distribute, combine like terms, and use all of those skills that we learned before. So what I'm going to do is I'm going to put this right here, x equals 2. And I'm going to erase what we have because we need a little bit more space. Because we have x equals, but we need to find what y is equal to. So I'm going to erase this. And I'm going to keep our y equals positive 2 over here. Okay. And that is part of that last step. Once we find that equation, then we're going to solve for that second equation. Remember, you could pick either equation to substitute into. I'm going to choose that first equation. It is easier to plug into whatever equation has that x equals or y equals. It makes it very simple. So I'm going to just rewrite our first equation. Sorry, that part of my computer screen doesn't really work. Okay, x minus 11. Okay, so now we're going to just plug in wherever we see an x. We're going to put that positive 2. And then everything else stays the same. So we're really substituting twice here. And then just solve from there. So when we multiply that, we get 12. Bring down everything else. And then when we subtract 12 and 11, we get y is equal to 1. So x is equal to 2, y is equal to 1. Make sure you write your answer as a coordinate, that ordered pair. X goes first, then y. So our answer here is 2, 1. So just to summarize, we identified which equation was that x equals or y equals, and then we took that, what it was equal to, and substituted into the second one to solve for that variable. Let's take a look at one more example. Okay, example number 2. Solve the following system of equations. We have negative 7x minus 2y is equal to negative 13, and then x equals 2y plus 11. So here we have an x equals equation instead of a y equals, which is fine because we're going to do the same process as we did in the last slide. I'm going to identify that equation and circle the little expression that it's equal to. Now we're going to take that expression and we're going to substitute it wherever we see an x. So make sure that you're substituting in for the correct variable. We don't want to put this where a y would be because it's not what y is equal to. It's what x is equal to. So we're going to substitute this over here where we see this x. So I'm going to rewrite this equation, and instead of writing x, I'm going to put that little expression 2y plus 11. So we have negative 7. So I'm going to put that in red. And instead of x, we're going to write 2y plus 11. And then everything else stays the same. So that minus 2y and that negative 13 stays the same. Now here I'm going to draw the train tracks, and I'm going to solve from there. First thing I notice, we have something right outside parentheses, so I'm going to distribute, and I'm going to get negative 14y minus 77. Remember, don't distribute outside the parentheses, so that 2y stays the same, and so does that minus 13. From there, I notice we have some like terms, so let's combine those like terms. That gives us negative 16y. And then I'm going to bring down this minus 77, and this equals negative 13. Keep solving. Add that 77 to both sides. Get that y by itself. Get negative 16y equals 64. Now let's divide by that negative 16. That cancels, and we get y is equal to negative 4. Okay, so we substituted in for x, and then we just solved the equation as is using those skills that we learned before. So now to save space, I'm going to just write our y equals negative 4 over here. Super important, so we need that piece of information. But I am going to erase this just so I have a little bit more space to solve for that second equation. Because remember, we only solved for y, so we have to make sure that we solve for x also. It's a system of equations with those two variables. So we have to make sure that we solve for x also because it's one of those. So because it is a system of equations, it has two variables, so we have to make sure that we solve for that second variable. All right, so you can choose either equation. I'm going to choose the one that is an x equals equation. It's usually the easier one, but it really is up to you. Just rewrite it. x equals 2y plus 11. And then I'm going to just substitute in for y here. So I'm going to write that -4 and then keep everything else the same. So x equals 2 and then times that -4 plus 11. Okay, let's multiply. We get -8 here. So x equals -8 plus 11. And then when we add those together, we get +3. X equals +3. So we have our x equals, we have our y equals. So our coordinate here is, right over here, 3, 4. Remember, a good way to check this is take these values, where x is 3 and y is 4, plug them in to your equation and make sure that they work for both of these. It's a really easy way to check. You do it right on the calculator, or you can write it out, either one, but it's a really great way to check. So make sure when you have a system of equations where we have an x equals or a y equals, you take that little expression that it's equal to, substitute it in for that variable, and solve from there.